Hey everyone! About 5 months ago, I put a video on YouTube showing how to connect an Arduino Mega to an ESP8266 module. I got a lot of feedback from that video, most of it positive, thank you very much, but there were also a lot of questions. So I thought I'd make a new video to address some of those questions. So this video won't make much sense unless you've already watched the previous video, so please go and watch that video if you haven't done so already. So in this video, I'm going to address some of those questions that were asked in the comments section, and I'll also show how to connect the same circuit using Arduino Uno board instead of an Arduino Mega board. So the first question that came up was when you first plug in an ESP module, like this. So when I just plugged in this ESP module, I got this message, Wi-Fi connected, Wi-Fi got IP. And many people, when they plug in their Wi-Fi module, they don't see that and they think that something is wrong. There isn't anything wrong with your ESP module if you don't see that. The reason why this is happening is I've used this ESP module once or maybe many times before on my home network, and it has saved my network settings on in its non-volatile memory. So the next time I power it up, it automatically looks for that same Wi-Fi again. And since I'm still in my house, it sees the Wi-Fi and automatically connects. If I flash this ESP module again, it will forget what it stored in memory, and you will no longer see this Wi-Fi connected, Wi-Fi got IP. So I'm going to flash this ESP again, and then you'll see that this doesn't happen. By the way, the wiring of this circuit is the same as the wiring that I used earlier in the video at about 17 minutes into the video. When you're flashing your ESP module, make sure all of your grounds are connected together. This is my power supply. It's a 3.3 volt supply, and this is the ground line on my breadboard. The ground is connected to the ESP module ground, and the ground is connected to the TTL, or the USB to TTL converter module. And when you plug in GPI 0, it gets connected to the same ground line. Okay, so I'm going to flash this ESP module again. One thing I didn't say in the video before, but I will say now, you have to, when you're going to run this ESP flasher, you have to shut down the serial monitor from the Arduino IDE. So close that down. Might as well close down Arduino IDE. Now we'll start the flasher software. I'm going to use the same firmware that I showed earlier in the video. I know that I'm on COM6. This USB connection is going to my COM6 on my computer. And now I'll click download. Failed to connect. Ah! Oh! Because I forgot to put GPI 0 to ground. That's another mistake that some people did. Cycle the power one more time. Download. Great. So, a couple things. Close Arduino serial monitor. Might as well close the Arduino IDE. Make sure GPI 0 is connected to ground when you're doing the flashing. And make sure you have selected the correct COM port on your computer. And then you just wait for the downloading to complete. Okay, so now the flashing is complete, and we'll check again the status of our firmware. So I start up Arduino IDE, I'll close the flasher, dual serial monitor, disconnect GPI 0 from ground, cycle the power, ready. So now this ESP module has forgotten where it is in the world. It doesn't know my network credentials, so it doesn't show Wi-Fi connected, doesn't show any IP information or anything like that. So this is normal. You just see, you might see a little bit of information like this. You see garbage, you see this AEI thinker, and then ready, and that's normal. Your ESP is working fine if this is what you see when you plug it in. And then you want to make sure you can talk to it, so we'll type AT plus GMR, and we get the version. And so we know that this ESP is working fine. Another thing people should double check when they're having trouble, make sure that your serial monitor is set to both NL and CR. Also, virtually all ESP modules run at 11/5200 baud. So make sure that you have that baud rate set correctly. Another thing that some people got tripped up on is the fact that they didn't have the proper libraries installed in their Arduino IDE. So if you go to Sketch, Include Library, you'll see what libraries are in your IDE, and for the sketches that I showed in my previous video and in this video, you'll need the Blynk app, the Blynk ESP8266 library, and if you're connecting the temperature sensor like I did in the previous video, you'll need Dallas temperature, you'll need one wire, and you might need wire as well. So if you don't have those libraries installed in your Arduino IDE, then the sketches won't compile and you'll have problems. Installing libraries is pretty easy, so just click on Google and you'll find those libraries, and you can install them. Blynk, the Blynk website even has a pretty detailed page about how to install the Blynk library for Arduino, so I encourage you to go to that page and install your Blynk libraries. I had a few queries from people who wanted to know how to build a similar circuit using an Arduino Uno instead of an Arduino Mega 2560. So I built that circuit here. In addition, I did the circuit without an ESP adapter, and instead I have a voltage divider to allow for communication, and I'm using a 3.3 volt supply that I used earlier in the video. So I have the circuit working. Button works. I did not put a temperature sensor in this circuit, but if you wanted to do something like that, it would be pretty much the same as what I did earlier in the video with the 2560. So I mentioned a few times that the ESP-01 typically runs at a baud rate of 11/5200. However, there are a few cases where you don't want it to run at 11/5200, and when you're running with the Arduino Uno with a software serial connection, that's one of those cases. In this case, we want to run the ESP-01 module at 9600 baud. That's about as fast as the software serial can handle communication on the Arduino Uno. So the next part of this video, I'm going to show how to change the baud rate of the ESP-01 module. So to change the baud rate of this ESP module, we're going to use the same circuit that I used to flash the ESP module. However, since we aren't going to be flashing, GPI 0 is left open. It is not connected to ground. So here we have our serial monitor. I can type AT plus GMR. So this is our ESP module. Right now it's running at 115200, which is sort of normal, but we want to change its baud rate to 9600. And so you type in this command. Hit return. You'll get an OK. And now we will disconnect the power. Because you get power from here to there, so you need to disconnect that power as well. Change the baud rate to 9600. So now our Wi-Fi module is running at 9600 baud default. Don't worry about this Wi-Fi disconnect. That's because my Wi-Fi module has some old Wi-Fi settings in it, and it is just trying to connect to a Wi-Fi network that isn't near here right now. So this is the circuit that we're going to be connecting. Notice that the serial port, or the serial lines on the Arduino Uno, are not connected to anything. That's because we're going to continue to use the Arduino hardware serial to send information to our serial monitor in order to debug the circuit. We're going to be using software serial on the Arduino Uno, and the software serial RX line is going to be pin 2. The software serial TX pin is going to be pin number 3. I'm going to be using a voltage divider in this circuit instead of using the ESP adapter board that I used earlier in the video. The voltage divider is pretty easy. It's basically two resistors, a 1K ohm and a 2K ohm resistor connected in series. I didn't have a 2K ohm resistor, so I just connected two 1K ohm resistors, but effectively it's the same thing. So the output of the TX line from the Uno board is at 5 volts. It goes to the top of the voltage divider, and then you get a 3.3 volt signal going to the RX pin on the ESP module. The RX pin of the Arduino board gets connected to TX on the ESP module. I'm using a 3.3 volt supply. The ground gets connected. I'm using this as basically my ground line on the breadboard, and 3.3 volts gets connected to CHPD and VCC. I also connect ground of the circuit to ground of the Arduino board. If you forget to do that, then you'll end up with different voltage levels on your circuit versus the Arduino board, and that will cause problems. But if you ground all of your, if you put all the grounds together, then everything is has the same reference, and you will avoid problems that way. I will also be, notice I also have ground connected to the ESP module. I'll also be using an LED in order to show that we can send a signal from my phone to turn this LED on and off. So I'm going to use digital pin number 7 on the Arduino board. I connect that to the LED through a 220 ohm resistor. This is the positive or the anode side of the LED, and the cathode of the LED or the negative side goes to ground. So that's the wiring of this circuit. Setting up the Blynk app is pretty much the same as last time, earlier in the video. You start a new project, we'll give it a name. The device that we're going to use is Arduino Uno, okay. Connection type, Wi-Fi, okay. Create project. So this says that it sent the token to my email address. I'll say okay. I will start a value display. Just like last time, I'll call this millis. The input pin is going to be virtual V5. Okay. Okay. And we'll add a button. We'll call the button LED. LED. Output pin. So we're going to use pin number 7 on the Arduino Uno. Digital 7. Okay. Okay. Great. Now our Blynk app is all ready to go. Okay. Next we're going to start working on the Arduino code. Again, I'm going to start from the Sketch Builder app in the Blynk website. Here we're going to choose the board Arduino Uno, and the connection is with a ESP8266. And then basically I took this code and copied it into the Arduino IDE, and then there were a number of things I had to edit, and I'm going to walk through that right now. Here's the authentication code, and that gets sent to you when you create your Blynk app. Here's my Wi-Fi settings. I'll update that later when I run the circuit. And here's where things get interesting. By default, the code is set for ESP serial 1, but of course there is no serial 1 on an Uno board. It only applies to Mega and I guess Leonardo and Micro, etc., etc. What I did on my code is I commented out that line, ESP serial, and then I'm going to use software serial for this sketch. So here's the commented lines. I uncommented those lines, and as you saw in the schematic, I already have my ESP connected to lines 2 and 3 on my Arduino Uno. We're going to talk to the ESP8266 using a baud rate of 9600. I'm not sure if that was, see that here the ESP is speaking at 115200, but I showed how to change the default baud rate on the ESP8266 to 9600, and that's what we're telling the Arduino that we're going to communicate with. Those are the key changes. Here's where I send millis to the Blynk app, and down here is another important thing. This is where you're telling Arduino that you want your debug information being sent to your serial monitor, and this would be a conflict with your 8266 if you're trying to run the 8266 with a hardware serial on the Arduino Uno. You can only have one device, you can only have one communication stream going on that one hardware serial of the Arduino Uno. And in this case, I'm letting the Arduino Uno use the hardware serial for the debug communication. There are ways that you can turn off the serial communication for the debug console, and then you can use the 8266 with hardware serial, but that'll have to wait for another video. So this is the code that I have. I'll have this posted in the description section of this video. So I've entered the authentication code in my Arduino sketch. I will upload the sketch. Done uploading. Start the serial monitor. Serial monitor. ESP not responding. Let's just try it one more time. Serial monitor. Here. Okay, that looks better. Now I'll start the app. Millis is running. I hit the switch. Nothing. Why nothing? There we go. So if I want that button to stay on, then I have to change this to switch. Okay. Play. On. Off. On. Off. All done. So if you've been trying to connect an Arduino Uno to an ESP8266, I hope you found this extra segment to be helpful. Give me a like on YouTube and subscribe to me. Thanks. Bye.